Welcome to this video on DOM-based cross-site scripting. In this video, we'll see how to detect and exploit DOM XSSs. The difference between this type of attack and the ones that you've seen in the other video is that DOM-based XSSs run exclusively on the client side. This means that the payloads are not processed by the server. They are processed only by the victim's browser. The application we are going to test is a new feature hosted on xssvictim.site, the donation form. As you can see, users can access the donation page from the top menu. The donation form asks for the donor's name, email address, credit card number, social security number, and the donation amount. Users can set whatever value they want. Moreover, in the footer, there are some links with different donation values. Let's take a look at the address bar. The amount parameter isn't passed to the server. It is actually passed to the page via the document hash. If we take a look at the page source, we can see that there's no input tag related to the donation amount, yet we can see it in the rendered page. This happens because the JavaScript code at the bottom of the page creates the input box on the fly. The function generates the input tag, extracts the amount value from the document.location.hash property, and puts the result on the page by using the inner HTML property. We can verify this behavior by changing the amount value in the address bar, refreshing the page, selecting the region with the amount input box, and then looking at the selection source. It contains the input HTML tag. On the other hand, the actual page source still doesn't contain any input field for the amount value. Any string passed via the amount parameter is rendered on the page. Here we test the page with the string payload. It's rendered on the page. The first thing we can try to inject is an IMG tag. Since our payload will be inserted in the value attribute of the input tag, we have to close the double quotes of the attribute, close the input tag, and finally, we can create our image tag. We set the image source to a bogus value, which doesn't exist, and then we inject an alert function in the onError event. The first payload is complete. Let's refresh the page to see it in action. As you can see, we successfully run some JavaScript code. Sometimes, we can make our payload smaller by using an invalid syntax and letting the browser fix it for us. Here we remove the double quotes around the src attribute. The payload still works. Another way to shrink our injected code is to build on the fly an SVG element. Once we get control over DOM function, we can change every element of the rendered page. In a minute, we'll change the action of the donation form to make it send data to an attacker-controlled site. This is going to be a complex payload. To craft it, we have to do some experiments with the browser console. So we go to the menu, Developer, and click Web Console. We want to modify the donation form action, so we first take a look at the document.forms object. This page contains two forms. The first one has index 0, and it's the search form. The second one is the donation form. Its action is the senddonation.php page. To change it, we have to change the action attribute on the form. We can do that by typing document.forms bracket 1 bracket dot action equals quotation test.html quotation. Now, if we click on the donate button, we see that the form posts the data to the non-existent test.html page. We can use this method to craft a URL, which overwrites the donation form action and sends the data to a URL under our control, hacker.site/steal.php. We will just have to reuse the command we typed in the console and insert it in the onload attribute of an SVG element. Hacker.site is hosted on our attacker machine. Let's take a look at the steal.php code. The script is very simple. It takes the credit card number and the SSN, and the social security number sent in the post request, and saves them in the loot.txt file. Let's test steal.php together with our payload. We point the browser to the malicious URL we created, fill the form with some data, and click Submit. As you can see, the data has been posted to hacker.site and has been stolen. Our payload is getting pretty complex, even if we used it just to change a single DOM element. What can we do if we want to create a more complex payload, like a payload which can perform multiple actions, such as cookie stealing, form redirection, or site defacement all at once? We could create longer and longer scripts and insert them in the onload event, or we could host a malicious JavaScript file on our hacker.site domain, and then append a script object to the DOM tree. Let's see the second approach in action. First, we create a simple JavaScript file on hacker.site. At this stage, we're just testing what we can do, so the file will contain a simple alert function. Now, we start crafting our payload using the browser console. We have to create a script object by using the document.createElement function. Then we set the source of the script to the hacker.site/s.js file. And finally, we append the script to the body of the document. As soon as we send our last command, the browser executes the alert function hosted on hacker.site. To complete our payload, we just have to copy the commands we typed in the console and insert them into the onload attribute of an injected SVG element. As you can see, the result is the same. We are now able to construct even a very complex piece of JavaScript code to take control over the user session in many different ways. We can inject everything we want in the output page, and we can modify our cross-site scripting payload without upgrading the malicious URL that the victim users have to click. Before concluding this video, we want to show you a very interesting property of DOM-based cross-site scripting attacks. Even if the URL carries the payload, this kind of attack cannot be stopped by anti-XSS filters. For example, the search function of this site is vulnerable to reflected XSS attacks. If we copy the URL and paste it in Chromium, the XSS is not triggered. Chromium XSS Auditor stopped it. We can verify this by opening the browser console. But if we try to exploit the DOM XSS in the donate page, we succeed. Remember that DOM-based and reflected XSS are completely different types of attacks. The former runs exclusively on the client side, while the latter is sent to the server. And this concludes our video on DOM-based cross-site scripting attacks. Thanks very much for joining us.